All right, let's jump right in. I'm going to come back up and read this, but example 1 says to write the augmented matrix for the given system. And so all we have to do is write the coefficients. So if my x coefficients are 3 and 4, my first column are going to be 3 and 4. My second column would be 4, -2. And then we put a little bar, a line to represent our equal signs, and then we have 7, 5. And that is literally all we need to do. Now I want to read this, and I wanted to do this first so that when we read this, we can kind of connect the dots and understand what it's talking about. But it says a matrix used to represent a matrix used to represent a system of linear equations is called an augmented matrix, in which each row represents the constant from one equation, both the coefficients and the constant on the other side of the equal sign. So what that means here is that this row right here represents this first equation, right? We have 3x plus 4y, our bars are equal sign, equals 7. So then my next row represents my second equation. We have 4x minus 2y equals 5. So each row represents the constants from one equation. And each column represents all coefficients for a single variable. So this right here, this column is my x column. We have 3x and 4x. This one right here is my y column. We have 4y and -2y, and then our equal sign, and it equaled 5 and 7. And then it goes on to say, and I've underlined it so that we can remember this, a variable that does not appear in the equation has a coefficient of 0. So we need to keep that in mind as we go to part B. On part B, to write our augmented matrix, I kind of like to go by the column versus the row. That's a matter of preference. So actually this one we went by column. Let's do row this one. On this one, the first equation here, we have 1x, we have -1y, 1z, and then my bar for my equal sign, and that equaled 10. Okay, so there's my first equation. So now my second equation. For my x column, we have 3. For my y column, we have 3 as well. But here I have no z, so that's what this right here comes into play. A variable that does not appear in the equation has a coefficient of 0. So we're going to put a 0 kind of as that placeholder, but that is the same as 0z. And then that equals 5. And then now my third equation is going to be 1, 1, 2, 2. And so we can read that by our columns or across from our equations. So let's go the opposite way right here. Now we need to write the system of equation that corresponds to the following augmented matrix. Then we will determine the solution of the corresponding system. So my first equation here, if this is my x, y, and z column, reads 1x, or just x, plus 4y plus 5z equals 3. My second equation is 0x, so you can write that, but that's not necessary, minus 3y minus 2z equals -6. And then my last equation here, 0x, 0y, we have 1z, or just z equals -3. So then it says determine the solution to the corresponding system. So now we need to solve, and this is just straight back substitution. I have what z equals here. Z equals -3. So now if I take my equation 2, I can plug in a z right here, or I can plug in my -3 in for z, and I can solve for y. So we get -3y minus 2 times -3 equals -6. Negative times negative makes positive. Subtract that 6 over. And then divide by -3. So we get y equals 4. Okay, so I have my z, I have my y. So now to get x, we have to go to equation 1 because that's the only equation that has an x in it. So I have x plus 4 times y, which is also 4, plus 5 times z, which is -3, and that should equal 3. So we'll have x plus 16 minus 15 equals 3. I'm going to combine these right here to get x plus 1 equals 3. Subtract your 1, and we get x equals 2. Now, again, on my math lab, it usually just wants x equals, has a blank, y equals, has a blank, and z equals blank, and you're typing in 2, 4, and -3. But I like ordered pairs. So this is x, comma, y, comma, z. X is 2, y is 4, z is -3. So that's my final answer there.